في ساحة للعلم كنا نلتقي والحب والإخلاص
Assalamu alaikum and welcome to another explosive, exciting mathematics show hosted by me, Mr. K from the QOA Institute and brought to you by Qurtuba Online Academy. Guys, I hope you guys have been following our series. I hope you've been watching all our shows. I hope you opened up a file and I hope that mathematics is now making sense to you. Over the past couple of shows, we've been doing sequences and series, and today we're starting with a big topic, guys, calculus. Now, calculus is worth 40 marks, 40 to 50 marks in paper 1, which is almost a third of your paper. So guys, get ready, get your scientific calculators out, open up your books, get your pens ready, take a deep breath. Let's get ready for today's session. Okay, if you missed any of the previous shows, don't stress. Go to Hilaal TV or to Qurtuba Online, click on their YouTube channel, and you'll see all the previous shows coming up. They're 1.5 hours each. You can go through them item for item, topic for topic. Okay, episode for episode. So without any further delay, let's get started with today's prep program based on calculus. Now, what is calculus? Many of you sit there, grade 12, you've done calculus for the year, but you don't even understand what is meant by calculus and why the need for calculus, right? Calculus is we are finding the rate of change, we are finding the gradient at any point. You know, for a straight line graph, right? You know, for a straight line graph, if I've got 2 points, and I call this X and Y, and there's another point X and Y, and we call that X1, Y1, we call that X2, Y2. When we're finding the gradient, when we are finding the gradient or the slope of a straight line graph, the M of the line, what formula do we use? You all know it, you've been taught it from grade 10. Y2, change in Y over change in X. So Y2 minus Y1 over X2 minus X1. However, what if I asked you to find the gradient? What if I asked you to find the gradient of any other graph besides a straight line graph? So if I gave you a parabola, or I gave you a hyperbola, or I gave you an exponential graph, or we gave you a cubic graph, how would you find the gradient at any point on these graphs? And that's why we have calculus. So for a straight line graph, we use y2 minus y1 over x2 minus x1. And for any other graph besides a straight line, we use what we call the derivative or first principles. The word derivative means finding the gradient. That's what it means, just finding the gradient. But we have different methods of finding the gradient, which you will be examined in your paper. So let's give you an overview of the entire calculus section that you're going to be examined for 2022. So I'm going to clear the screen here. Let's start off with calculus, and let's start off with what you need to know. Right, so let's start off with a mind map. We're starting off with a mind map. The first question in your exam would be to find the derivative by using first principles. Now, what is first principles? It's finding the derivative using the formula. You all know that by now. I know it's end of the year. You've written your prelims already, or you're going to write your prelims, and you're going into finals already. So you've done all of this. And what is the formula? F dash X, the general gradient. The general gradient on graph F is given by the limit as h approaches 0. We all know f of x plus h, y2 minus y1. Remember the gradient, y2 minus y1 over x2 minus x1. So f of x plus h minus f of x all over h. And there we go. Whenever they ask you to find the gradient or to find the derivative by using first principles, we use the formula. So these are the topics. This is your first question in your paper, and this is going to be worth 5 marks. Okay, you know that we're going to build up to about 40 marks for your final exams. This is the whole overview of the entire calculus section for 2022. Right, paper 1. So let's go. First principles. Then you've got the derivative, which is the shortcut or the power rule. Right? So instead of us using the formula, there's a shortcut. And we use the power rule. I'll explain to you this when we do the examples. Number 3, differentiation. Differentiation is finding the derivative for more complex. It's the process of differentiation for more complex equations or functions. Right. Then you have finding the equation of a tangent. Finding equations of a tangent to a graph. Finding equations of tangents. Then we have what we call the cubic graph. Right, the new graph, the cubic graph. The equation of a tangent, if I've got a parabola and there's a tangent passing there, that tangent is given by y is equal to mx plus c. That's what they want you to find. The equation of that tangent to a function at a point. Then you got the cubic graph, how to sketch, how to find equations. And then we have the last topic, which is called optimization. And optimization means calculus application. And there we're going to be using volume and total surface area. We might do it in terms of graphs, and we might even do it in terms of speed, velocity, acceleration. We will be doing all these topics. Let's put a mark allocation, just to give you an idea, a general mark allocation of what each one would be. First principles, 5 marks in your exam. Derivative, 3 marks. Differentiation, 5 to 6 marks. Finding equations of tangents, about 6 marks. The cubic graph, about 12 marks. The total, not only the graph and all the questions about the graph. So 12 to 15 marks. And calculus optimization, 10 marks. Let's see how many marks does this give us. 10 plus 12 is 22 and 6 is 28. 28 and 5, 33 and 3, 36 and 5, 41. So we're looking at plus minus 40 marks. Now guys, 40 out of 150 marks. It's almost a third of your paper, right? Remember, this is maths paper 1. So you need to ensure that you score full marks here. Because if you score full marks in your algebra, full marks in your functions, so algebra would be about 20 marks. Your functions, all the graphs that we've done, remember we've done sequences and series and functions. Functions another 30 marks, right? So 20 and 30 is 50 and 40 is 90. You already got 66.666, about 67% for your paper. Then you still got finance, right? You got your sequences and series and you got probability. And that's going to give you your 150 marks for your paper. So this is the overview, guys. These are the topics that we're going to be completing in the next couple of episodes or in the next couple of segments to ensure that you master calculus. We're going to do this in as detailed as possible. We're starting from the first topic, first principles. So take these topics down. We've got 6 topics. 1, 2, 3, 4, 5, 6. This is the entire overview of calculus, your calculus component for maths paper 1. Okay, this is grade 12 only. Grade 11s, you can just watch and enjoy the show. All right. So you've taken this down. This is the topic. We're going to go through it item for item. We've got 6 items to complete. Let's start it from scratch. Okay, so here goes. Let's start off here with our first topic here, first principles. So put the heading there, first principles. All right, first principles. So let's go. Question number 1. If f of x, now this is, I'm not only using this as an example to show it to you, I'm actually I'm showing you a template that you can use. So all you do in the exam is you change the values, but you follow, you unpack the process, right? If f of x is equal to 5x squared minus 3x, find f dash x, the general gradient on f of x, by first principles. This is your command. This is your instruction for you to use the formula. How many marks would that be? 5 marks in the exam. The minute they say by first principles, you know it's your command to use the formula. You never ever use the formula again. You'll be using the power rule or the shortcut later on. But for now, for question number 1, under calculus, you will be using first principles. Okay, so take this question down. If f of x is equal to 5x squared minus 3x, find f dash x by first principles. We know what our formula of first principles is. I gave it to you. F dash x, f prime x is equal to the limit as h approaches 0, f of x plus h minus f of x all over h. You know that. So now we got f of x. There's f of x. So we've got f of x. What am I short of? F of x plus h. So if this was f of 2, for every x, I'll put 2. If this was f of a, for every x, I'll put a. If this was f of h, for every x, I'll put h. This is f of x plus h. So that means step number one. Step number one. And I want you to use this as a process, as a procedure in your exams. So in your answer, again, I'm telling you, like I say all the time in all the previous episodes, guys, what I'm doing on the screen here is not rough calculation. You will answer it step by step, exactly the way I unpack it on the screen. You can copy and paste it in your exam. I'm giving you templates. I'm giving you models. Okay, so let's go. That was your question. Now watch. This is where you start answering in your exam. I know many of your teachers at school say go straight into the formula. Don't. Right? Just hear me out. First get f of x plus h. You got f of x. There we go. That's f of x. I need f of x plus h. So before going into your formula, hear me out. Before going into your formula, first let's get f of x plus h. So f of x plus h is equal to, for every x, what must I put? For every x, what must I put? X plus h. So we got 5 into x plus h squared minus 3 into x plus h. I'll tell you why. Because it will help you to copy and paste it into your formula. The minute you go into your formula, you might run the risk of getting the algebra wrong. So let's do this. This is step number one. Now let's remove the brackets. This is 5 into x plus h squared is x squared plus 2xh plus h squared. Now multiply these two out, minus 3x minus 3h. Now multiply all this out, you're going to get 5x squared plus 10xh plus 5h squared minus 3x minus 3h. Right, so we got f of x, we now got f of x plus h. So like I said, guys, like I said, this is step number one. Step number two, go into your formula. Now write down your formula. You must write your formula, you get a mark for it. What's your formula? F dash x, the general gradient, the derivative, the general gradient on graph f is given by the limit as h approaches 0, f of x plus h minus f of x all over h. Now we substitute. So we go the limit as h approaches 0. What is f of x plus h? There it is. So what do we have? 5x squared plus 10xh plus 5h squared minus 3x minus 3h minus f of x minus 5x squared plus 3x. The minus here, the negative here changes both those signs. Plus 5x squared becomes minus 5x squared minus 3x becomes plus 3x. All over h. Now let's collect our like terms. Let's see what we can cancel out and what's left over. Right, so plus 5x squared minus 5x squared is 0. Minus 3x plus 3x is 0. We want to cancel this h. So now we take out the highest common factor. The highest common factor of h. So let's take out h on the top. Because there's a h there, there's a h there, there's a h there. So let's take it out. Let's take out h. What am I left over with? I'm left with 10x. There we go, 10x plus 5h minus 3 all over h. Why did I take out that h? To cancel with the h at the bottom. Now you are left with this. After you've cancelled the h, now you say, you can carry on at the bottom. I'm going to move over to the side because of space. Right, now you're going to say, but h approaches 0. Therefore, f dash x is equal to, here's your final answer. But h approaches 0. So what is 0 times 5? 0 times any number is 0. What am I left with? What am I left with? 10x minus 3. 10x minus 3. And there we go. That is your derivative. And you can check it using your power rule. You're in grade 12 already. You know the power rule. 2 times 5 is 10. X minus 1 times 3 is 3. You don't think you're right. You know you're right. All right. And there we go. So step number 1, f of x plus h. Step number 2, f dash x. You use your formula. Step number 3, you substitute into your formula. Step number 4, you take out h as your highest common factor. Step number 5, you insert h here. H times, you insert 0 for h. 0 times 5 is 0. You're left with 10x minus 3. There's your final answer. So it's done in 5 parts. It's done in 5 parts. So this is an easy one, right? And it's also, like I said, it's asked in most papers, right? They might even change. They might say minus 3x squared plus 5x. Doesn't make a difference. You just follow the same procedure. Put in your values, unpack it the way I've unpacked it, and make sure that your algebra is correct. Multiplication, division, you must know how to remove your brackets. Okay, this was example number 1. Now, many of you say that you've seen in a past paper where x is in the denominator. This is a parabola. Now, remember, it's always 1 power less. If the original is a parabola, your derivative is power 1, which is a straight line. So it's always 1 power less than your original. Your derivative, your gradient, is 1 power less than your original. This is power 2. This would be power 1. Right? 1 power less. Minus 1. Ting, 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 ting. Ringing a bell? You'll see it when we come. Remember the minus 1. 1 power less. Good. That's going to bring us to the power rule, which is our next topic. Okay, let's do another example of this. Let's do another example of this. So you've taken this one down, practice on it, master it. You don't need to do 50 examples. Do 2 or 3 examples, master the process. It's copy and paste in your final exam. Okay, what if we gave you f of x? Watch this one. They can even give you g of x. Let's do it in terms of g. G of x is equal to 3 over x. Find, this is a question in the exam, if g of x is equal to 3 over x, find f dash x by first principles. 5 marks. 5 marks. That's your question. Here's your answer. Let's start it step by step. I know you're smiling. I know you're smiling. Matriculants, grade 12s, I know. Core math learners, I know you're smiling. You've seen this one before. You've done it. You've attempted it. In fact, you can start it now. Before I even start it now, you guys can start doing it. Right? You don't need to wait for me. All right. But you want to see how I unpack it? Let's unpack it together, guys. So now, let's start. What did I say? Step number 1, we say g of x plus h. So g of x plus h would be 3 over x plus h. Right? Remember I said for every x, we're going to put x plus h. Now, what was the second part? The formula. So we're going to go g dash x is equal to the limit as h approaches 0. Right? F of x plus h. So g of x plus h minus g of x all over h. So your limit as h approaches 0, g of x plus h would be that. So it's 3 over x plus h minus 3 over x divided by h. Watch what I do. Divided by h over 1. Why did I move it? Why did I move it from here to the side? Because I don't want to work with a fraction over a fraction. It's easier to work with it like this than to work with it with a fraction over a fraction. It becomes too complex. Okay, now divided by h, watch what I do. Limit as h approaches 0. This is normal algebra now. Here I'm going to tip and times. Multiply by 1 over h. We can change the division to multiplication and flip it over. It's the same thing. Now here I'm going to find the LCD. In algebra, I'm going to say x into x plus h. That's my lowest common denominator. Whenever you're subtracting two fractions in algebra, LCD. So x plus h will cancel. You're left with x. X times 3 is 3x minus x and x will cancel. X plus h times 3 is 3 into x plus h. I don't need to teach you this. This you've been taught from grade 10. How to add and subtract fractions. Right. The limit as h approaches 0. Let's simplify this. 3x minus 3x minus 3h. I'm multiplying that out. All over x squared plus xh times 1 over h. 3x minus 3x is 0. Right. The h here and the 1h there on the top cancels out. So what am I left with? Let's move over to the side. I'm going to say the limit as h approaches 0. You keep on doing, insert the limit right through until the end. You got minus 3. You got negative 3 over x squared plus xh. Now you say, but h approaches 0. Therefore, now you drop the limit because you're inserting the limit here. 0 times x is 0. Therefore, it's not f dash x, it's g dash x. So let's go back. Therefore, g dash x is equal to minus 3 over, you're only left with x squared. And that's your final answer. So it's negative 3 over x squared. That's your final answer. This is also an exam type question. A question like this would be worth 5 to 6 marks in your final exams. Okay. Guys, I hope you've understood what we've spoken about. We're coming towards the end of our first segment. I hope you guys are enjoying the show, right? Brought to you by Qurtuba Online Academy, QOA Institute, and Hilaal TV. I'm your host and presenter, Mr. K. Hope you guys enjoyed this. Stay tuned with me for our next segment. I hope you guys just tap out, go through your notes during the short ad break. When we come back, we're going into derivative and differentiation. Guys, enjoy your break. Okay, guys, welcome back to our explosive show. I hope you guys are enjoying. You guys enjoyed the first segment, right? We've done calculus. We started with calculus. We did first principles. We're now into the second segment. If you've missed it, go back, or you can check tomorrow. It will be uploaded onto YouTube under Hilaal TV or Qurtuba Online Academy's link. So, guys, we're starting now with the derivative, which is the second part of our component. Remember, I told you first principles, derivative, differentiation, finding the equations of tangents at a point, the cubic graph, and optimization. We're now doing the derivative. Now, the derivative we're going to be using is the power rule. Now, it's the shortcut. Remember, in our first segment, we had f of x was equal to, let's say, 5x squared minus 3x. That's the question. Now, if the question says find the derivative, or if you need, this is a tool, it's a process. So if you need to find the derivative, what we do, we say f dash x. Now we're not using the formula. Now we are not using that formula. Remember the formula for first principles? F dash x equals limit as h approaches 0. F of x plus h minus f of x all over h. We're not using that anymore. Why? It's only worth 2 marks. Right? You want to find the derivative. So we use what we call the power rule. It's the shortcut. So what is the power rule? We take the power. Let's go here. We take the power. We multiply it by the coefficient. We take the power. We multiply it by the coefficient to get your new coefficient. And then we minus 1. Remember we said it was 1 power less? We minus 1 from the power to get your new power. And we do this for each term. Alright, so what do we have here? Let's make this a little bit more interesting, and let's put here plus 6. Right, now find the derivative. So what are we going to do? We're going to take the power times the coefficient. There we go. Power times coefficient to get your new coefficient. So 2 times 5 will give me 10. X minus 1 from the power. So 2 minus 1 is 1. Right? Now we go here. 1 times negative 3 is negative 3. X to the power 1 minus 1 is 0. And what is the derivative of a constant? Is 0. The constant terms fall away. Why? The number 6. X equals 6. Let's go to x equals 6. There's the number x equals 6. It's a straight line going through 6. Does that line have a gradient? No, it's got no slope. So the derivative of a constant is 0. The derivative of a constant is 0. That's why your constant falls away. Okay. Let's go back. And that's it. That's your answer for that question. Let's go back. We got 10x minus x to the power 0 is 1. 1 times 3 is 3. And there we go. Can you see we got from question to answer in one step without using the formula? Now, if you go back to the previous segment and you saw the calculus formula that we had, the derivative formula. The answer to it was 10x minus 3. So we skipped all that process and we use this. So you might ask the question, so can I always use this? You will always use this if they don't ask you by using by first principles. This is not first principles. First principles is using the formula. When you're just finding the derivative, you just use what we call the power rule. Let's go through the power rule again. What is the power rule? We take the power times the coefficient, power times coefficient to get your new power, and then minus 1 from the power to get your new power. So 2 minus 1 is 1, and then 1 times negative 3 was negative 3. 1 minus 1 is 0. The derivative of a constant is 0. Let's do a couple of examples of this. Right, here's another example of derivative, right? So let's give it to you in terms of y. Y is equal to 8x cubed minus 5x squared plus 10x minus 2. You want to find the derivative. So you say dy over dx. You don't say if it was f, you say f dash x. If it was g, you say g dash or g prime, whatever your teachers call it, right? So we're going to find the derivative. That's the question. Here's your answer. You want the derivative. So we are differentiating y in terms of x. So what are we using? The power rule, not first principles. 3 times 8, power times coefficient. 3 times 8, 24. X, 3 minus 1 is 2. 2 times minus 5, minus 10. X to the power 2 minus 1 is 1. 1 times 10 is 10. X to the power 0 is 1. And the 2 will fall away. And there's your final answer. That is your derivative. That is your general gradient of your original. Okay? So you've taken this down. That's derivative. So if it's in terms of f, you put f dash x. If it's in terms of y and x, you say dy over dx. They could ask you the same question. Just watch this. Just watch this. What if they gave it to you in this format? I'm just showing you the different formats. If they gave it to you like this, I know you've seen this in the exam. They give it to you like that, dx. It's the same thing. When you are finding the derivative, don't go and say d dx, right? This is the proper format. The minute you're applying the power rule, you just say is equal to. The minute you say is equal to, you informing the examiner or you informing the person who's reading, I am now applying the power rule. That's what it means. So now you just say is equal to, and now you apply the power rule, and that's your final answer. Okay, so that wraps up. So if it's in terms of f, f dash x. If it's in terms of y, dy over dx. And if it's in terms of dx, dx, then all we do is we say is equal to, and we apply the power rule. All right, so there we go. That's the derivative. So scratch that out from that, from the topic list, from the checklist that I gave you in the previous segment. Guys, I hope you're enjoying the show. I hope you guys are processing all the information. We're now going to go into about 3 or 4 different examples of differentiation. All right, so let's go. Let's go. Put the heading differentiation. Now we're doing differentiation. Now differentiation is finding the derivative for more complex equations, and it's done in 3 parts. How many parts? 3 parts. Okay, what are the 3 parts? B, D, A. You do it in part 1, part 2, part 3. Right? These are the rules. These are the rules of differentiation. Okay, we're going to do an example. We're going to do about 4 or 5 types of examples here on this side. But these are the rules of this game. Remember, mathematics is a game, right? We show you the rules. You take the rules, you apply it, and as we go along, level 1, level 2, level 3, they start getting a little bit more complex or more complicated. But remember, the rules help us to simplify. That's the object in mathematics, to simplify a complex situation. Okay, so let's start with B. What does B stand for? Before. So before you differentiate, right? What do we need to do? So it's done in 3 parts. Part 1, part 2, part 3. So before differentiation, we need to remove brackets. We need to remove surd signs, or we need to remove unknowns from a denominator if a fraction is given. From a denominator if fractions is given. What we want to do is we want to make it linear. We want to put it in a straight line. Okay, I like using the example of differentiation. Imagine you are about to assassinate 3 people, right? Or a group of people, let's say 5 people. You want to assassinate them. And it's a bleak example, but let's use it just for the sake of the show. So you're about to decapitate. You know, in the olden times, in the mid-18th century English times, you want to decapitate a person, right? You know, heads rolling, sword swinging, right? Blood spurting. I think you can picture it, right? Imagine you were about to assassinate 3 people. So what would you do? Number 1 or 5 people. You put them in a straight line. So step number 1, the before. Before we assassinate them, we put them in a straight line. Now if they got jackets, if they've got clothing, what you want to do is before you do the decapitation, you want to remove their clothes. You want them in their simplest form. So that's it. We remove the brackets. So in maths, clothing in mathematics, clothing, jackets, boots, backpack, rifle, hat, is your brackets, your surd signs, unknowns from denominator. We want to make them linear. We want to put the people who we are about to assassinate in a straight line. Right. Death by differentiation. Now comes the sword action. Remember, power times coefficient minus 1 from the power. So here goes your sword action. Right, so let's go. Now we use the derivative. So before, B for before, D for death by derivative. Derivative. That's the power rule. So remember our sword action? We took the power. What's the power rule? So imagine you had a sword in your hand. So you start on the top. Power times coefficient. Right? Remember power times coefficient. Power times coefficient. And make sure the head is off. Slice the head off. Minus 1 from the power. Make sure you do both actions. Right? Make sure you go down. The head is probably hanging. And then slice it off to make sure that the heads roll. Okay, so derivative, we're using the power rule. Power times coefficient minus 1 from the power. Right? I know it's a very dark example, but I think you know where I'm going with this. And after differentiation, obviously now the family wants to come and see the people who have been, so you want to put them, you want to make them smile, you want to make them look positive. So what you do is you attach, you stitch their heads back onto their bodies, right? What a dark example. But anyway, can you picture the whole thing? Right. Before, we put them in a straight line. Death by derivative, the sword action. And then you got after differentiation. You want to, so this is the after. After A for after. You want to write that with positive powers. You want to write your answer with positive powers. So these are our rules. Guys, these are our rules of this game. It's called the assassination rules of differentiation. Right? So finding the derivative, you assassinating. Think about it. Just picture the whole scene. Let's start with type number 1. Let's go. Example number 1. Right. They tell you to differentiate. So here's it. So what does differentiate mean? Assassinate. Right. Let's assassinate this question. What does it look like? So let's say type number 1. I tell you y is equal to, let's give it to you in terms of y. Now I tell you, it's the square root of x minus 4x squared plus 5x all over, let's say, x. Now, what is so peculiar about this type is that we've got one term in the denominator. So type 1 is when you got one term in the denominator. What are we going to do with that one term? Let's start with the before part. Let's get them linear. Let's get this in a straight line. So here you use your normal rules of algebra. Now in algebra, when you got one term, you know this one term belongs to all three. So in your answer, where do we begin? I want you to pay attention. Pay attention carefully. So we got y is equal to square root x, you know, is x to the power, your inside power divided by your outside root. So it's 1 over 2. Divided by x to the power 1. Minus 4x squared. You split it up. Divided by x to the power 1. Plus 5x over x to the power 1. Now we're not differentiating yet, guys. We're not differentiating yet. All we're doing is we're making it in a straight line. We are simplifying a complex equation. So therefore, y is equal to x to the power. When you're dividing and bases are the same, you subtract the powers. So a half minus 1 is minus a half. Minus 4. X to the power 2 divided by x to the power 1 is x to the power 1. Plus x and x will cancel. You're left with 5. There we go. That's the before part. That's the before part. That is, we've now put all our people, all our victims in a straight line. Now we're going to apply the derivative, the power rule. So let's start the assassination process. Are you ready? Right, you can hear the trumpets blowing and people throwing tomatoes and lettuce at the people who are going to be assassinated. Right, so let's go. Therefore, dy over dx. There's it. The sword is coming down. What's the sword action? Power times coefficient. Minus a half times 1 is minus a half x. Remember, slice the head off. So we got to subtract 1 from the power. Minus a half minus 1 is minus 3 over 2. 1 times minus 4 is minus 4. X to the power 1 minus 1 is 0. And the 5 will fall away. The derivative of a constant is 0. Now, that was the derivative. Now we do the after party. What's the after party? Before, derivative, and after. Right? So here goes. Minus 1 over 2. X to the minus 3 over 2 will come down in the denominator is x to the power 3 over 2 minus 4. And there we go. There's your final answer. You will get about 3 to 4 marks for that one. Okay, so there we go. The first example, let's just highlight it for you. Before, that's your before part. That's your before part. That's your derivative. There's it, BD. And that's your A. PDA, PDA. Before derivative, linear. Derivative, power rule. After derivative, write your answer with positive exponents. Finish. Problem solved. So BDA, guys, BDA. So this was example number 1. Now example number 1, like I said, is type 1. This could be x, it could be the cube root of x, it could be the cube root of x squared. Doesn't make a difference. As long as it's over one term. You split them all up and you work out each one independently to get them in a straight line. Then you apply the power rule. Let's do example number 2. Let's do example number 2. Going to be quite different. Let's say it's now in terms of f. So let's say f of x is equal to, let's say, x squared minus 2x minus 8 over x minus 4. Now I want you to find f dash x, or I want you to differentiate. What? That's the question in your exam. In your answer, let's do the before part. Remember, this is not simplified. We need to simplify it first. Right. What is the difference? Let's ask you now. What is the difference between the first one that I gave you and this one? The first one, you had one term in your denominator. Remember, we gave you x. This one here, we got two terms in the denominator. Now, in algebra, when you get two terms in the denominator, how will you simplify? You'll factorize and cancel. What do you do? Whenever you have two terms in your denominator, in algebra, you factorize the numerator and you cancel. And that's how we'll get rid of this denominator. So let's go. F of x. This is the before part. So let's factorize that. That's a perfect trinomial. It could be a trinomial. It could be a difference of two squares. It could be grouping. You need to know your rules of factorization. All over x minus 4. Now we know if we factorize that, what would that be? X minus 4, x plus 2. Now we know that and that will cancel. So f of x in its simplest form, in its linear form, is only x plus 2. Therefore, f dash x, the derivative, 1 times 1 is 1. X to the power 1 minus 1 is 0. The 2 will fall away. X to the 0 is 1. 1 times 1, and your answer is 1. Do I need to write it with positive powers? No. It's already 1 is 1. It's already with a positive power. Okay, and that's your final answer. This is type number 2. This is type number 2. We're going to do another 2 or 3 types. Okay, let's see the next one. Let's see if you can do the next one. Let's see if you can do. So this was example number 2. All right, take it down. Pause your screen. Okay, if it's live TV, you can't pause your screen. But obviously, you're going to re-watch these episodes on the Qurtuba Online or on Hilaal TV website. Okay, so you can watch these episodes over and over until you can do this without anybody helping you. Okay, the purpose of me right here is just to show you how it's done. To master it and to practice on it, that is your homework. That's for you to do. That's your job. Okay. Let's look at another one. Let's give it to you in terms of y. Y is equal to x minus 1 over square root x minus 1. Differentiate. Find dy over dx. Question, answer. Let's go. How would you do that one? I know you're sitting, you're crapping cop, scratching your head. Body's starting to itch. I know. You're sitting, you're looking at it and saying, now what do I do? Where do I begin? We got 2 terms in the denominator. We've got 2 terms in the denominator. We've got to factorize and cancel. So we're going to go y is equal to, that is a difference of 2 squares. Difference of 2 squares. So it's root x minus 1 into root x plus 1. Ah, didn't see that one coming, I bet. All over root x minus 1. Because root x times root x is x. Minus 1 times plus 1 will give me negative 1. And there we go. That's your difference of 2 squares. Smart, ne? X minus 1 will cancel. We're left with y is equal to root x plus 1. So y is equal to x to the power 1 over 2. 1 over 2 plus 1. Right, so now we got it in its simplified form. That's the before part. Now we apply the derivative. We haven't yet differentiated. Now we say, therefore, dy over dx is equal to power rule. Half times 1 is a half x. Half minus 1 is minus a half. And the derivative of 1 is 0. I told you a constant term, a known term, a fixed term. The derivative is 0. Write this with positive powers. 1 over 2 x to the power minus a half will come down as plus a half. And there we go. That's your second example. That's another example. It's another type that you could possibly see in your final exams. Right? So don't let them catch you. Don't let them catch you. Okay? All right. We're almost to the end. We're almost to the end. Yes, time flies here in studio, guys. Time flies. And you guys must be thinking, sure, I wish we could have this the whole day. You think you can manage a whole day of math, non-stop? Stay tuned. So when we advertise our live workshops, okay, they're coming up soon. So here we go. This is done. What I'm going to do now, I'm going to leave you before break. Right? We're going to cut for an ad break. So what we're going to do, that's our session for now. Before we cut for break, I'm going to give you one to do during break. And let's see when we come back if you can work this one out, right? So if you're following, I hope you are following. Let's give it to you again in terms of y. I'll tell you y is equal to, let's put it in, let's say 4 times the cube root of x plus 3 over 5 times the square root of x minus 4 over x plus 2. I want you to find dy over dx for 5 marks. We're going to cut for break. We're going to cut for break. 4 times the cube root of x plus 3 over 5 times the square root of x minus 4 over x plus 2. After break, we're going to work out the memo. Enjoy your break, guys. Hope you guys are enjoying the show. Stay tuned for our next segment. Assalamu alaikum and welcome back to our explosive show, guys. I hope you're enjoying this our segments today on calculus. We started a new topic. This is our third segment for today. This is the final segment for today. We've done calculus, we've done first principles, we've done derivative. We are busy with differentiation, right? I left you with a question before break. Let's see whether we can mark it and whether you've got it right. Okay. So right, grade 12s. Let's start. That's the question in your exam. That is your answer. If you missed the first two segments, guys, don't stress. Go to Hilaal TV, go to the YouTube channel, click on it. You'll be able to get the entire episode back to back, and it will be uploaded the day after our live show. Okay, so let's go. Remember we said derivative done in 3 parts, BDA. So let's get this in a straight line. Y is equal to 4. This here is x to the power 1 over 3. There we go. Plus 3 over 5. We leave the 5. Remember we said get rid of unknowns from denominator, not knowns. Here we go. That is a known. So we leave it. 3 over 5. Square root x is x to the power a half. Minus, there's an unknown, that will come up to the top, 4x to the minus 1 plus 2. So there we go, we've got it in a straight line. That is the before part. Let's do the derivative. Let us do the derivative. We are now going to apply the power rule. So what do we have? We got y is equal to a third times 4 is 4 over 3. In fact, we're going to say therefore dy over dx, derivative. 4 over 3 x to the power a third minus 1. So 1 over 3 minus 3 over 3 is minus 2 over 3. A half plus positive times positive is a positive. Right. 3 times 1 is 3 over 5 times 2 is 10. X to the power a half minus 1 is minus a half. Negative times negative is a positive. 1 times 4 is 4. X to the power minus 1 minus 2. The constant term falls away. Is that my final answer? No. What must I do? Write it with positive exponents. So it's 4 over 3 x to the power plus 2 over 3 plus 3 over 10 x to the power plus a half plus 4 over x to the power 2. You might ask the question, do I need to put it back into third form like that? No, you don't. As long as you leave it with positive exponents, you can leave it. I know rules have changed slightly over the past couple of years. I'm talking about examining rules, not math rules. Examination rules have changed. Sometimes your teachers say, no, you can leave it with a negative power. Guys, just be sure. Make sure that you answer it. As long as you have positive powers in your final answer, you can't go wrong. So it will take you maybe 10 seconds more, but you might as well know that your answer is correct. All right, so there we go. dy over dx. Let's do one more. Now this last one is going to be a bit hectic, right? Let's see. So I'm going to erase. I hope you've taken it down. Let's give it to you in this form. Let's give it to you dx. And I tell you, I put brackets here. I say 3 times the square root of x minus 2 times the cube root of x all squared. For 6 marks, differentiate. Differentiate. Question in your exam? Answer. Where do we begin, guys? This is where it gets hot, where your seats start getting hot, grade 12s. Right? You are now in the hot seat. Right? You can feel it. It's burning, nah? Let's go. What do you think we're going to do with this? What do you think we're going to do with this? Watch how we unpack it. Now it's squared. We need to remove the square. So watch what I do. I say dx. I'm still simplifying. This is the before part. So let's go. 3. This is x to the power 1 over 2. 1 over 2 minus 2x to the power 1 over 3 squared. Agreed? Agreed. Right. Dx. We're still not done. we need to remove those brackets. So I'm just going to do it this way. I could have done it the shortcut way, but you probably would have got confused. You would have got lost. So I'm just going to expand it out for you. So we're going to do 3x to the power a half minus 2x to the power a third into, because it's squared, we're going to copy and paste 3x to the power a half minus 2x to the power a third. There we go. We still need to remove our inside brackets. We need to remove that. So we still dx. Right. Let's remove the bracket. So what we're going to do now, guys, you got 2 terms times 2 terms. So we're going to FOIL it out. First, outer, inner, last. My 2 first terms, my 2 outer terms, my 2 inner terms, my 2 last terms. What are we doing? We are multiplying. We are multiplying. We are not adding, we are multiplying. So 3 times 3 is 9. X. When you're multiplying and bases are the same, we add the power. So a half plus a half is 1. Right? A half. Remember, we're not multiplying. We're not saying a half times a half. Although we're multiplying our rules of exponents, when you multiply and bases are the same, you add the powers. So half plus a half is 1. That's your first term. That's your first. Your 2 first. Your 2 outer. Positive times negative is negative. 3 times 2 is 6. X to the power a half plus a third is 5 over 6. Now my 2 inner terms minus another 6x to the power 5 over 6. And my 2 last terms, negative times negative is a positive. 2 times 2 is 4. X to the power a third plus a third is 2 over 3. We're not yet done. Let's collect our like terms. Let's collect our like terms. You got 5 over power 5 over 6, power 5 over 6. So we're going to go dx still. We haven't yet differentiated. Minus 6 is minus 12. Right? Let's go back there. Minus 12. X to the power 5 over 6. Plus 4x to the power 2 over 3. There we go. We've removed the brackets. We've collected our like terms. All I did was I FOILed it out. First, outer, inner, last. First, outer, inner, last. We collected our like terms and there we go. We've now got it in a straight line. Now we differentiate. Now we differentiate. This is equal to, let's go, power rule for that, that and that. Right, you can use your calculators if you want to. 1 times 9 is 9. X to the power 0. 1 minus 1 is 0. So that's 9. Positive times negative is a negative. 6 goes into 6 once. We're multiplying, remember? So 6 goes into 12. 2 times 5 is 10. X. 5 over 6 minus 1. Remember, minus 1 is minus 1 over 6. Positive times positive is a positive. 4 times 2 is 8 over 3. X to the power. 2 over 3 minus 1 is minus a third. Can that be my final answer? No. We got to write it with positive powers. So this would be 9 minus 10 over x to the power 1 over 6, that comes to the denominator, plus 8 over 3. X to the minus a third will come down as x to the power plus a third. And there we go. That's your final answer. You will get 6 marks for that. Lots of writing, lots of numbers, but it's a language. If you understand what we're doing, this is actually a picture, like a Picasso, right? Like Mona Lisa or whatever, a Da Vinci painting. Maths is an art. You know exactly, to an untrained eye, this looks just like a whole lot of numbers that are just thrown onto the screen, splashed onto the board. But there are steps involved. And you know what's interesting in that? Maths teaches you how to internalize and how to practice your own religion. I know you might be asking, now what is this guy talking about? He's talking about religion and he's talking about math. And where are the two related? Like I said, to an untrained eye, hear me out, to an untrained eye, this looks like a whole lot of numbers just thrown on the board. But to a trained eye, this makes absolute sense. It makes perfect sense. And you know exactly, you see the whole picture. So some people, let's just talk a little bit about religion, right? Some people say, no, we do anything. Don't worry, God is in our hearts. God is in our hearts. It's not about anything. We don't need to pray. We don't need to follow all the rules. Why did God give you the books? Because He gave you rules. To an untrained eye, you look like you're doing nothing. A person making salah, a person praying. To an untrained eye, what's he doing? But to a trained eye, he knows exactly. It makes perfect sense. Right? A person says, no, I'm making a fire. I'm dancing around a fire and I'm worshiping. Well, you can do what you want to. I'm worshipping. I'm throwing a whole lot of numbers. If I wrote a whole lot of numbers on the board, that's just numbers. It's just numbers. You can go and write your final exam. Anybody can go and write a matric final exam. Just go and write a whole lot of numbers and say, I should get a distinction. I'm going to be successful. I will pass. How? How? Have you followed the processes? Does it make sense to you? Yes, you threw a whole lot of numbers out. Is that math? No, it's not. Right? So mathematics helps you to put things, even your own religion, no matter what you are, whether you are Muslim, Christian, Jew, Hindu, makes no difference. You're following a higher order. Your higher order has given you an order, a process to unpack. Unpack that process in the way your Lord wants you to unpack it. Not in the way you want to or you feel like you want to do it. And then you say, I'll be successful. Don't worry. That's between me and God. What a joke. It's between you and God. So all right. So if that's your rationale, if that's your thinking, then for your final exams also, don't prep for it. Don't watch the show. Don't watch me teach you how it's done. Just go and write a whole lot of numbers. Go and put plus, minus, go write. Whatever comes to your head, do it. Then say, of course I'll pass. I'll be successful. Maths is in my heart. It's between me and my examiner. Between you and your examiner. You will fail. Nicely, beautifully you will fail. Okay, so I'm just putting it into perspective, guys. That's what math teaches you. There are laws, and then the laws make sense. Apply the law, get the right result. Don't apply the law, well, you face your own consequence. You face your own judgment in life. Each man for himself, each to their own, right? So there we go. We are done with this. We are done with the differentiation. I know you said, why? How come he digressed? He diverted from... No. It all makes sense, guys. We can't just do numbers. All this makes sense to put together into a final picture. Okay, so we're done with differentiation. Right? We're now coming to the end of our episode. Okay, I hope you guys have enjoyed this. Remember, in the next part of calculus, now we're going to get where... we're going to turn up the heat again. We're going to turn up the heat again. We're now going to do finding equations of tangents at graphs. We're going to do the cubic graph, and we are going to do optimization in our next episode. Ladies and gentlemen, boys and girls, teachers, parents, I hope you guys have enjoyed the show. I hope you guys are enjoying this Qurtuba Online Mathematics show. We talk a lot here in the studio. There's a lot of numbers being written here, but remember, there is so much of seriousness that's attached to this, because this is going to determine whether your child or you, the learner, grade 12 learner, whether you're going to pass your final exams for 2022 or not. From me, Mr. K, QOA Institute, Qurtuba Online, and Hilaal TV, I say Jazakallah for watching our show today, and stay tuned for our next explosive episode where we're going to be finalizing calculus. From me in studio, Assalamu alaikum wa rahmatullahi wa barakatuh.
في ساحة للعلم كنا نلتقي والحب والإخلاص زاد قلوبنا نمضي إلى نور اليقين ونرتقي قمم الفلاح وتاجنا أخلاق